Bubbles and bubblegum involve interesting scientific principles related to the behavior of gases, surface tension, and the properties of polymers. Let's explore the science behind bubbles and bubblegum. 1. Formation of bubbles. Surface tension. The formation of bubbles is primarily influenced by surface tension, a property of liquids that causes them to minimize their surface area. Water molecules at the surface of a liquid experience a net inward force due to cohesive forces with neighboring molecules. This creates a thin film with higher surface tension. Gas pressure. Bubbles form when a gas, typically air, is trapped beneath the surface tension of a liquid. The gas exerts pressure on the liquid, creating a spherical shape. The balance between surface tension and gas pressure determines the stability and size of the bubble. 2. Composition of bubbles. Thin film of liquid. Bubbles consist of a thin film of liquid, usually water, which is surrounded by a layer of gas, typically air. The soap or detergent added to the water reduces surface tension, making it easier for the bubble to form. Soap molecules. Soap or detergent molecules have a hydrophilic, water-attracting, end and a hydrophobic, water-repelling, end. The hydrophobic ends embed themselves in the liquid, while the hydrophilic ends point outward, reducing surface tension and stabilizing the bubble. 3. Stability of bubbles. Thickness of bubble film. The stability of a bubble depends on the thickness of the soap film. Thicker films are more stable, while thinner films are prone to rupture. The Laplace pressure, which is inversely proportional to the radius of the bubble, contributes to the stability of small bubbles. Evaporation and condensation. Bubbles can burst due to evaporation or condensation. If water evaporates from the bubble's film, it becomes thinner and more prone to bursting. Similarly, if water condenses on the film, it can disrupt the stability of the bubble. 4. Bubblegum. Polymer properties. Bubble gum is made from polymers, long chains of molecules. The gum base contains elastomers, which give it its stretchy and rubbery properties. This elasticity allows bubble gum to form bubbles when inflated with air. Sugar and sweeteners. Sweeteners like sugar or artificial substitutes are added to enhance the taste of bubble gum. The sugar also provides a source of energy for the bacteria in the mouth, leading to the production of acids that can contribute to bubble gum's ability to form bubbles. 5. Blowing bubbles with bubble gum. Inflating the bubble. When you chew bubble gum, you create a flexible and stretchy material due to the polymers in the gum base. Inflating a bubble involves trapping air within the gum and stretching it into a thin film. Chewing and saliva. Chewing increases the temperature of the gum, making it more pliable. Saliva also contributes to the formation of bubbles by adding moisture and making the gum more elastic. Bubble bursting. The stability of a bubble blown with bubble gum is influenced by factors like the thickness of the gum film, the elasticity of the gum, and environmental conditions. Thicker and more elastic films contribute to longer-lasting bubbles. Conclusion. The science behind bubbles and bubblegum involves a combination of principles related to surface tension, gas pressure, polymer properties, and the interplay of various substances. Whether it's the delicate beauty of soap bubbles or the fun of blowing bubbles with bubblegum, understanding the underlying science adds a layer of fascination to these everyday phenomena.